Telephone company technicians are required to work near commercial power sources that can reach levels of hundreds of kilovolts. These voltage levels are extremely hazardous, and contact with any of them must be avoided. The safety of our employees is and always has been an extremely high priority. Today, you will be shown a new test set for your use that will replace the voltage detector you are familiar with. The purpose for using the new test set is the same, a tool to detect the presence of commercial power hazards. With the new test set, which we will call the Foreign Voltage Detector, or F.V.D., contact is not required. It needs only to be in close proximity to the source. Detection through painted surfaces, even wire insulation, is now an easy task.
When the sixth step of the bar graph is activated, 50 volts of AC have been detected. Along with the sixth bar graph step, another indicator, an audible alarm, will be activated. The audible alarm will remain active as long as more than 50 volts is detected. The remaining indicator is a green LED located just below the bar graph window. This LED doubles as a power on indicator and a battery condition indicator. With a good battery, the LED will remain illuminated anytime the power switch is depressed. When the LED fails to illuminate, the battery must be extinguished. You are now ready to test.
To test with the F.V.D., turn it on a few feet away from the suspected source. When all of the bar graph steps deactivate, point the probe toward the suspected source and slowly move toward it. If the audible alarm sounds at any time the source is greater than 50 volts, continue toward the suspected source until the alarm sounds or the probe tip is touching the source. If no alarm has sounded when the source is touched with the probe, the source is less than 50 volts. If hazardous voltage is detected, you must proceed in accordance with established policy for your company. The F.V.D. can detect voltage only. This means that conditions where large currents are flowing and voltages are kept very low will not be detected by the F.V.D. Always look for indications of high current, such as discoloration, excessive heat, smoke, etc. Always follow your company's safety policy when placing or removing temporary or permanent bonds while dealing with potential high current situations. Because the F.V.D. is a remote sensing device, there are some testing situations that will produce different results. The situations require procedures that may be unusual or new to you. A large surface such as this will give a higher reading than we get on a small gauge wire pair. This is true because the F.V.D. makes use of the coupling through the small capacitance between the F.V.D. probe and the source. The larger the source then, the more capacitance is present, and the greater will be the coupling. This mobile home has been purposely energized to 120 volts, as would be common in case of a power fault within the structure. Our F.V.D. is indicating considerably more than 120 volts. It should be noted that any facility, such as this home, a metal building, metal conduit, virtually any conductive surface that should be grounded should not read any AC voltage. If any is detected, the grounding of the facility should be suspect. At this site, we have a power line operating at 230,000 volts with a telephone pedestal almost directly underneath. This voltage level produces an extremely high electrical field, often referred to as an E field. If we point an F.V.D. toward the line, we get an immediate alarm. If you test this technician, you will find that he is energized. These indications are caused by the electrical field between the power line and nearby conductive objects. These are not false indications. The indicated voltage does exist on the objects. The voltage is coupled through a very small amount of capacitance and at a low frequency, so there also exists a very large amount of opposition to the coupling. To us, this means there is almost no capability to produce damaging current flow, so the observed voltages are not dangerous. They are also very easy to remove. Watch what happens to the indication on my partner when we connect him to a simple ESD wrist strap that is grounded. The same thing happens when he contacts anything that is conductive and goes into the earth. This same phenomena will give an apparent false indication when we test a grounded object, such as this pedestal, if the operator is not grounded. The best way to overcome this is for the operator to ground himself by any safe means at his disposal and test the pedestal or cabinet. Here is a case of capacitive coupling that many telephone technicians will recognize. There are two C-wire runs. One is terminated, the other is unterminated or floating. Now, notice the indications when we test each with the F.V.D. The floating C-wire appears energized, while the other is not. In this situation, the floating C-wire is capacitively coupled to AC power over the length of the run. You should avoid contact with this C-wire. This coupling can give a shock strong enough to cause one to fall or otherwise injure oneself. It is recommended that a visual inspection of the route be made to determine that no physical hazards exist. After this has been determined, to make the situation safe, simply connect the floating C-wire to a temporary ground. Always retest with the F.V.D. after the ground is placed. And remember to follow your company's safety policy when placing or removing temporary or permanent grounds. When working aloft, an operator can make use of the shielding effect of the cable or strand being tested. As seen earlier, a grounded conductor will shield an operator from being coupled to an electrical field. Keeping this in mind, you would always approach the cable or strand to be tested from below. That way, the cable or strand itself will serve as a shield for the operator, avoiding the false indication that could otherwise occur. There is often confusion over induction, power contact or partial contact, capacitive or E-field coupling, and ground coupling. Partial contact and ground coupling are similar and should be treated the same. If the voltage is at a hazardous level, either one can be dangerous. Inductive coupling occurs because of the magnetic field that surrounds a current-carrying conductor. It should be noted that this is the method used to produce electric power and to drive electric motors. The ability of induced voltages to produce current flow is then obvious, so it should be treated the same as contact and ground coupling. Capacitive coupling is different. Some AC will couple across any capacitance, as we saw at the site under the 230 kilovolt line. However, current flow through this capacitance varies directly with the amount of capacitance present and the operating frequency. At 60 Hertz, the frequency is low and capacitance is very low, so current flow must also be extremely low. Capacitive coupling at 60 Hertz then should not be considered a hazard. A condition can exist whereby large currents can flow while voltages are quite low. As long as this condition persists, it is not hazardous. If, however, this circuit is opened so that the current flow stops, the voltage on one side of the open can immediately reach dangerous levels. Always treat potential high current situations as hazardous. Always look for indications of high current, such as discoloration, excessive heating, smoke, etc. Test current-carrying conductors with the F.V.D. before making any contact with them. Always follow your company's safety policy when placing or removing temporary or permanent bonds. When testing a device that is cyclic in nature, such as a traffic light support strand, the operator should always test through at least one complete cycle. This will avoid missing detection of a fault that occurs on a single phase of the cycle. In summary, the F.V.D. has been designed to overcome many of the limitations of previous test sets. The small size and ease of operation make it a very useful tool. However, no tool can be of value if it is not used. Keep the F.V.D. with you and use it at every opportunity you have.